Okay, the last part of function theory is the inverse function. And the idea of the inverse function, so the inverse of f of x is denoted as, this is not an exponent, it's not f to the negative 1, it's the, when you see this f, like negative 1x, the inverse, okay? And basically it reverses the action of f of x. So the inverse of the function actually is equal to x. And the idea is if f goes to some y, then the inverse function takes it back to x. Now, so what you're seeing here is like the switching of the x and y. Bear with me for a second. I'm going to teach you in a while how to find the inverse. And the first step is to switch the x and the y. Okay, so I'm going to ask you to go to Desmos right now, and I want you to plot two functions. So first thing, you're going to plot y equals x squared. Now, we know what y equals squared x. Y equals x squared looks like this. The next thing I'm going to do is ask you to go to Desmos and switch the x and the y to come up with the inverse function. Now, Desmos is going to give you something that looks like this. And the first thing that should strike you is, hey, wait a minute, Mr. Adler, that's not a function. So we have to, the problem is we're interested in functions that have inverse functions, okay? So what we're going to do is we're going to take it, so the idea is for a function to have an inverse function, f of x must be 1 to 1. Now, I'm not going to get into it. The idea is that every x value only goes to one y value. I'm not going to get into that. I'm just going to say, I'm going to reintroduce something. Like with functions, to prove that something is a function, it passes the vertical line test. For something to be 1 to 1 and have an inverse, it must pass the horizontal line test. And simply put, it's the same criterion as the vertical line test. If you draw a horizontal line through the function and it passes it through more than one point, it does not have an inverse. So we're only interested, so original function must pass the vertical line test. We're going to see here that the parabola does not pass the vertical line test. What we're going to do in a more advanced class is restrict the domain. So we're going to restrict the domain. Now, this is not part of SL, it might be part of HL. Restrict the domain. So if we take out this part, what happens is this ends up going away, and so our function has an inverse that's a function. Okay, so once again, the horizontal line test, we're going to get back to that in a second. So let's pick up where we left off. So we can say that two functions are inverses if and only if, don't worry about that, if, let's say we have f of g of x is equal to, if we switch it around, and they both equal x. So in the same way that if we take the inverse of the function, we take that back to x. If we have two random functions and they get you back to x, they're inverses of each other. So for example, let's see, show that f of x equals 2x plus 4, and g of x equals x minus 4 divided by 2 are inverses. So you might have taken a class where you were told to pick a function, switch the x and the y, solve for y. Let's hold off on that for a second. The idea is we have two functions. Let's use the lessons from the composite functions to determine if this is an inverse. So let's put g inside of x. Let's put g inside of x. Well, f is 2 blank plus 4. So you know what? I said let's put g inside of that. 2 goes out with the 2. X minus 4 plus 4 equals x. Okay, that's taken care of. Now let's put f inside of g. Let's put f inside of g. Well, g is blank minus 4 over 2. F is 2x plus 4. We have 2x over 2, which equals x. Nice. So because f of g of x equals x, and g of f of x equals x, f and g are inverses of each other. Now, specifically, let's get to the good stuff. Now, once again, the algebra might work. But it also has to pass. It has to be 1-to-1. So let's see. So let's talk about 1-to-1. 1-to-1. The idea is, so let's take a couple of functions. Well, we already looked at the criteria. It's the horizontal line test. If it passes the horizontal line test, then it has an inverse. If you think about this, we know that in the parabola, we can have many of x values going to the same y values. But if we flip it around, that one goes to many. That's the visual problem. Once again, this is many to 1. So if f of x is many to 1, like A, B, C, and D, but if the inverse is 1 to many, so this is not a function. Not a function. So the inverse is not a function. Okay, let's take a look at some examples. Let's see. F of x equals 4x plus 2. Well, I kind of know the graph looks like this. How we do? Oh. So let's see about this. Well, I know it's a function because it passes the vertical line test. And I know it has an inverse because it passes that horizontal line test. Perfect. So this has an inverse. Next example. The next example is f colon arrow x squared plus x arrow x squared plus 1. Well, I know what the picture looks like. I know it kind of looks like this. Now, I definitely know it's a function. I'm fine with that. The problem is we saw in the previous example, it fails the horizontal line test. So the vertical line test, that's okay. But the horizontal line test, no. So does not have an inverse. Let's try another one. G of x is equal to the square root of x plus 2 minus 3. Well, you can see from your GDC, we know it's going to be 2 to the left, down 3. So it's kind of like this. Because once again, we know from our domain, this can't be less than -2. So -2 is the beginning of the domain toward infinity, and then we know it starts at 0, -3, and then goes up. You can see that from the GDC. Look at the table of values. Question is, does it have an inverse? Well, let's see. It passes it is a function, and it passes the horizontal line test. VLT, nice. HLT, nice. It has an inverse. Good. Now, let's get to the stuff we know. How do we find, so the rule is, so finding f in the inverse, the idea is switch the x and the y. Now, we saw actually, this is kind of interesting, when you switch the x, it turns out from geometry, when you take a point and reflect it over the line y equals x, the result, the image is yx. So what you're going to see is when a function and its inverse are like reflections over the line y equals x. So let's see, f of x equals 2x plus 1. Find the inverse. Well, first of all, does it have a function? Yeah, we know that lines pass the vertical line test and the horizontal line test, so we're in good shape. So let's see, we know that this is y equals 2x plus 1. Switch the x and the y, solve for y. Nice. So f of x equals 2x plus 1. The inverse function equals 1x minus 1 over 2. And then let's just do a couple of techniques. So we're not going to do quadratics, but we are going to do, look at cubics. So for example, if I say, let's say g of x equals x to the third minus 5, what's the inverse function? Well, first of all, I know that my graph, you can look in the graphic calculator, it's the cubic shifted down 5. So it passes the horizontal line test, it passes the vertical line test. There is an inverse. Let's see how we can solve for this. We have y equals x cubed minus 5. The inverse is x equals y cubed minus 5. X minus 5 equals y cubed. How do we undo a cube? We take the cube root. So y equals the cube root of x minus 5. Okay, the last technique I want to show you, this will show up in I just want to get this down. Please practice this. You're going to be given the function y equals 2x plus 5 over x minus 3. Now, we're going to see in a little bit that this actually looks like, let's see, 3, and then here, and then where is, let's see. Oh, I'm sorry, that's wrong. We'll see this in a later lesson. And then the question, how do we graph this? Well, it kind of looks like this. No, I apologize. 3, 2. So it kind of looks like this. So you're looking at this graph and you're like, that's weird, Mr. Adler, but no. The fact is, it passes the vertical line test, it passes the horizontal line test. It has an inverse. So I just want to show you the algebra for this. So let's see. If this is the function, this is the inverse. Okay, step one, cross multiply. Now the idea is we want to get the y's alone. So bring all the y's to the left, bring all the x's and the constants to the right. Factor out a y. And we have y equals 3x plus 5